Welcome back to the course. Now we are going to build the fruit predictor, a model that can determine whether a fruit is a banana or an apple. Let's first look at an apple and a banana and see how they differ and what features we can use to tell them apart. Feel free to pause the video to come up with your own ideas. The first thing you notice is that they are different in shape. They are different in length, smell, width. They are also different in weight, probably, but we haven't tried that. Other features are also possible as long as they vary between those two fruits. Our fruit predictor will use only two of those features, namely length and color, since they are the easiest to measure with the sensors that are in the Lego set. Before doing the machine learning part, we first need to assemble the device itself. The built-in instructions are on the screen. Feel free to pause the video and take your time assembling the fruit predictor. You can also find the instructions on our web platform with a link provided in the description of this video. Here is the fruit predictor. It has a caliper that will measure the length and a color sensor here. Let's collect some examples for the fruit predictor to learn from. For that, I have already connected my Lego Hub to the web platform. The link to the video showing how to do this is in the description. First, you need to start the program by clicking on the button Start Program. And wait. When the program is started, you'll see a notification in the bottom left corner on the website. Like this one here. To measure the color, simply take the fruit and bring it to the color sensor. Hold it approximately half a centimeter away from the color sensor and click on the right button. A square in the bottom right corner indicates that the color measurement is saved. Then place the fruit into the caliper, close it, and remove the fruit. And then click on the left button in order to measure the length. The data point is in the diagram now. The diagram itself has the length of the fruit on the y-axis and the color from how red it is to how yellow it is on the x-axis. You can also find the data point in the table, where you can either delete the data point or change its label in case you forgot to select the right one before doing the measurements. Now I'm going to collect more data. I have 4 more bananas and 3 more apples, and I'm making sure they are all slightly different so that I add some variety to the data. I proceed as before. I take the fruit, I bring it to the color sensor and click on the right button. Then I measure the length of the fruit and I can see the data point in the diagram now. I do the same for the rest of the fruits that I have. The data is collected. It's time to decide how to use this data to make a prediction. To do this, we will use an algorithm called k-nearest neighbors. It works as follows. For a new data point that we want to predict, we first measure the distances to the other points. Then we select its 3 nearest neighbors, which is where the name of the algorithm comes from. Finally, we take a vote amongst the 3 nearest neighbors. If the majority of them are apples, we say that the unknown fruit is also an apple. If the majority are bananas, we say that the unknown fruit is a banana. We could also make more neighbors participate in the vote, but 3 is enough for our purposes. Now let's see if it works. An important rule of model testing is to separate the data on which you train the model from the data on which you test it, because we want to see how good the model is at recognizing a pattern, not how good it is at remembering what we have already shown it. So we are going to move the training data to the side, and I've got a spare banana and a spare apple that I didn't use for the training. I will switch the model to prediction mode, and I will proceed as during the collecting training data. I will measure the color. I will measure the length. I will turn it to you so that you can see that the fruit predictor says it's an apple now. Now we can do the same with the banana. We measure its color. Then we also measure its length. And you can see that it says it's a banana. You can also see the predictor data point in the diagram on the website, along with its 3 nearest neighbors that participated in the vote. And so, we've completed all the steps needed to bring the model to life. We started with the idea of distinguishing apples from bananas based on color and length, gathered the data, and built the model using the k-nearest neighbors algorithm. Normally there would be a training phase, but since k-nearest neighbors doesn't require one, we skipped that step. After evaluating the model, we found it works and works good, and now it's ready to use. But let's experiment a bit more. We know that the model can tell apples and bananas apart. What if we try to trick it? What if we show it an orange? Pause the video and think about what might happen. First, let's look at this orange. When we measure its length, it falls somewhere between the banana and the apple. And when we measure its color, it's orange. It's between the red and yellow, and is neither of them, right? At the same time, the computer has to pick either an apple or a banana, because those are the only options it knows about. It doesn't have a button to press that says, sorry, I don't know, or this is something else. All it has are two answer options, banana or apple. So it will pick one of them. The fruit predictor will work as usual. It will measure the distances, find 3 nearest neighbors, vote, and tell us it's either an apple or a banana. And we can try it ourselves now. The model is in the prediction mode. We first measure the color. We also measure the length of the orange. And you can see it says now it's an apple. That's an important point to understand. The model does exactly what you designed it to do. We created it to differentiate between apples and bananas, without training it to figure out that it's something else, or that it's an orange. And the model does exactly what we designed it for. It tries to tell whether fruit is closer to being an apple or a banana. We tried to trick the fruit predictor with test data. What if we try to make the training data weird? First, let's turn on the decision border. The decision border will show an area where it would predict an unknown fruit to be an apple in red, and area where it would predict an unknown fruit to be a banana in yellow. And the separation looks pretty reasonable now. The longer the fruit is, and the more yellowish it is, the more likely this fruit to be in a banana. And let's just try to change two labels from each side and see what happens. As you can see, it has completely strange form now, and it's obviously a bad separation, which is expectable. We confuse the model with bad examples, giving it false clues about the relation between features and labels. Therefore, you should keep the data clean. If you're not sure whether a data point has the correct label assigned to it, it's always better to simply delete it rather than confuse the model. You can experiment with collecting more training samples and changing the number of points participating in the vote by adjusting k, which is why it's called k-nearest neighbors. Once you are done, join us in the next video where we'll build a picture that always hits the target. See you there!